How's everyone doing today? Gosh, I muted myself. Why would I do that? I don't know. How's everyone doing? Who all do we have in the chat? Busy morning right here. My hair is getting all crazy. I guess it gets longer. Noel, good to see you. What should we do? You name the question, we do the question. I feel like I have lint on my shirt. Black t-shirt with lint. That's the way it goes. So if you name a question, we will do said question. I feel like the camera, I'll say, that's way out of frame. I'm gonna fix the camera again right here real quick. You ready? We're fixing camera real quick. Chapter 5, part 1, homework or quiz? Chapter 5, part 1, homework or quiz? Which one of those should we do? Chapter 5, part homework, quiz, or what should we do? There. Wow, holy mackerel. There we go. Oh, see, now I'm out of frame. Oh, you know what I didn't do? I need to zoom out a little bit. 1 second, then we'll... Woo! Zoom out. There we go. Zoom out. So, zoom out. I feel like I made mistakes with my camera. Mistakes were made. There we go. There we go. A study looked at a rising cost for average wind speed, or the rising average wind speed in the Hopkins forest. Yes, and that's the quiz. Let's do the quiz question. Let me redo this. That's better. There we go. We're more in frame. I like this. That's what I wanted. That's what I've been wanting the whole time right here for the camera. Okay. And I need to save it. Store as one. Store. I think I've done it. Hopefully. Looks good. Thank you so much right there. I tried using previous homework hour videos, but my calculations came out different years, even with different numbers, students, same numbers. Oh no! Let's go get that question right here. The Hopkins, it's chapter, oh, is this the one with the, is this the tree? It's average wind speed, okay. We're gonna go grab that question and work on it. Thank you for being here. And we're gonna go find that question and answer all the questions. Answer all the questions. Here we are. And Mewbot's here. Let's throw out some Mewbot points. The Hopkins Forest. Mewbot's handing out those Mewbucks. So many Mewbucks. Is he gonna do it? He better. I'll pay him to hand out money. Or Mewbucks. Okay, this is the... I think I got the wrong one. I clicked on the homework, I think. Wind events. Wind events on the quiz. Chapter 5, part 1. Here we go. And we'll click in here. Did I get it on the first try? Let's find out. Okay, heading over to the main screen. Okay, here we go. Let's find that wind events one. We'll mark it in the notes right here. Here we go. We found it. This one, I think this is one of the weird ones where you have to like shift the data. And we'll talk about how to do this one. This is a tricky one. We haven't done one like this lately. So let's mark it right here in the notes at 453, stat 201. Go away, Adobe. And chapter 5, part 1 quiz. And a study looked at Hopkins Forest. And Forest is way, there we go. Okay. So let's take a look at what the question has right here. They're recording the wind speed, and the outliers had values of 6.727, 3.926, 2.528. And this is for February, June, and August relatively. And then they give you the mean and the standard deviation for all of these months right here. Now, here's where we run into small issues, not big issues, but small ones. Is that all of these means in notation are what? Every single mean is a what in notation. Every single mean is a what in notation. So think about the notation for mean. Every single mean is a what in notation. Well, every single mean is mu. So when you hear the mean, all of these are different mu's. The standard deviation are all different sigmas. So what are we missing from the equation right now to solve for the z-scores? Yeah, no worries. It's all practice. Good answers, Noel. So what are we missing to solve for the z-scores? The what? And then what is that? So this is practice with knowing what the equation is, how to find the equation, what these things are just when you write them down. So what are we missing from the equation? Because we want to find z-score. So what are we missing? What are we missing? What are we missing from that equation? The y, which y is the observed. Y is the observed value. And so we want to go back here and we want to write down the observed value for each observation. So the observed value for each observation, or for each month, is that in February it was 6.727, and we'll write y right here, which is the observed. That means you felt the wind at that speed, you observe it at that speed. In June, it is 3.926, and in August, it is 2.528. Once again, this means you walk outside and you feel the wind going this speed. You would expect it to be the mean. The standard deviation is a measure of variation, and then you observe or feel it in this month going this speed. So we're trying to see, is that an unusual high speed that you felt? And all we're going to do is plug in these numbers. I'll do one of them right here so you can see the steps. We're going to find the z-score for February is the observed for February minus the mean for February over the standard deviation for February. And this gives us the z-score for February's outlier. It's going to be like 2.7 or so, maybe. I'm taking a guess. So observation minus mean over standard deviation and 2.79. And we're going to copy and then annotate down decimals till we get to the right amount and round. So there we go right there. We're going to do the same sort of things. We're just putting in the numbers of observation. Remember, the observation is going to go to 3.926. We're just plugging in the observation for June minus the mean of June, which is the yellow number for June. And then observation minus mean over the standard deviation, 7,952. And we get a much higher z-score by basically one higher. Stat to a 1 coming up here soon. And then lastly, we're going to do observation minus mean over standard deviation. For the last numbers here, we're just going over to August. And the observation for August is 2.528. Did I miss a decimal on that? I feel like I did. No, there it is. It's only 3 decimals. 2.528 minus the mean of 0.632 divided by 0.5969. And just make sure you enter the numbers in the right way or you will not get them correct. And there's the numbers there, down to 2 decimals and round. And June had the craziest event right there. Does that make sense, Noel? Let me know. But the key is to know the formula, and then you will just change the numbers throughout this, knowing that the observed value is right here, knowing that the standard deviation is what you divide by, and you're trying to find out the difference between the observation and the mean. And that's what a z-score analyzes, is this difference in terms of standard deviations. So does that make sense? Noel, tell me if you have any questions on this. I hopefully didn't go too quickly. You just take the numbers here and plug them into the formula and do it for each month. How does that look right there? So trying to turn each value for each month into a z-score tells you how weird and unusual those values are. So that's kind of the goal right here, is to figure out, are these values unusual? Are they far away from the mean? And I got to make sure it hits save. I think I didn't hit save during yesterday's office hours, and I lost all my notes. What question should we do next? Let's do another question. I had a tiny bit late start right here today, but what question should we do next? We can do any question people want. Just pick another question or say, let's review this. Yep, you just take observation minus mean over standard deviation and do it 3 times each month. And then the one with the most extraordinary will be the z-score that's the highest. So the most extreme. It doesn't go negative, so they're just asking the highest z-score value. Which one should we do next? Pick another question. Might need to send out reminders and say, hey, everybody, we're streaming online. We'll say chapter 5. I'm going to go email the class and be like, chapter 5, we're doing it. Don't be stuck on chapter 5. I'm going to look at grades right here right now real quick. Here, I'll go to the main screen. Can you do the question about the Forrester measured? Yeah, Kylie. Homework or quiz? Homework or quiz, Kylie? I'm going to send out a tell me homework or quiz. And say chapter 5. Quiz question, okay. Forrester measured. It's chapter 5 part 1 you're working on, right? I'm gonna say chapter 5 help right now. Chapter 5, help. Join in. Click here. We are live. Come in and ask questions on what you're stuck on. Here. Oh yeah. Sending one quick. Let's click everywhere now. Make sure it goes to it. There we go. Okay, cool. Oh my gosh. Okay, that's got it. Sending that out. Chapter 5, help. Currently streaming. Okay. Forster measured. Let's do it. And the Forster measured. Forster measured. Company with rivets. Forster measured. We got it. Thank you, Kylie, for being here. Let's throw you some points. And we're going to do this Forster measured question right here at the 12:33 mark. Stat 201. Chapter 5. Part 1 quiz. And a Forster measure. What is, they got obsession with Foresters and forests. Okay, so the first part of this question is the empirical rule. So when it comes to the empirical rule, when you get to your test, the first thing you should do is what it out. The first thing you should do when you get to the test is what it out. I had an amazing graphic this morning. The first thing you do when you get to the test is what it out. Draw it out. So what we're talking about right here is you want to immediately, when you get to your test, once you start it, you can't bring this to the test, you want to draw this out right here. So this is the 68, 95, 99.7 rule. And it's also broken down really well. And what you would do with a problem is when you're working on a problem, you want to go here and you want to put your numbers below. So let's see how we would do this if it was a test question and we didn't have my Pearson directing us what to do. So you'll see the worksheet here in a moment. Here we go. You'll notice it says the mean is 10.7 and the standard deviation is 4.9. What we're going to do, just for brevity, is we're going to say it's normally distributed with a mean of 11 and a standard deviation of 5. Now, I know those aren't the numbers. I'm just doing those numbers because they're nicer. They're easier to write. Now, once again, use the real numbers, and we'll show how to use them right here. What goes right here, Kylie? What would go right here? What would go right there at the center of the curve? What would go right there at the center of the curve? What would go? It would go 11, exactly. So we're going to put 11 right here at the center of the curve, and then we're going to go ahead and go up by standard deviations of 5. And nice job, Kylie, right there. So we're going to go up by standard deviations of 5. And once again, you can use the exact numbers. I'm just doing it because it's easier to round the numbers, but on the test, I would use the decimals. So if you notice right here, we're going up 3 standard deviations, and we're going down 3 standard deviations. Now we'd look over here at the question and notice 68, 95, 99.7, 11, 6, 1, and -4. This is the right answer. It should go 68 in the center. I guess I might have to make this a little bit bigger so we can see the expand the window thing. But if you notice right here, 68 is in the center, 95 and 99.7, and that's what they're showing right here. 68 is the middle 68 between a z-square of -1 and 1. Christopher, good to see you right there. We're working away. Ask questions if you got them. And so that is the correct graphic, and we can use that graphic now. Well, the next question is the middle 68%. Well, where's the middle 68% between? Look at my graphic on the screen, and you can pick the real numbers. Where's the middle 68% between? And here's the rounded version. Once again, use their graphic, but it doesn't hurt to draw one of your own to practice. The middle 68% between. Where would the middle 68% between be? Where would that be? Exactly. And the more exact numbers over here, 5.8 to 15.6. And so we're going to go ahead and enter 5.8 to 15.6. What percent of trees should be below 5.8? Well, on our drawing over here, that's going to be right here. And think, if 68% is between here, how much is one of these blue arrows worth? So we're asking, if 68% is between, how much is one of those blue arrows worth? Great job, Kylie. I hope this is really good practice. So it says below 5.8, which is this number right here on our graphic, rounded version, 16, because if you add up, you should get 100%, because 32% would be outside, 16% right there. Next, we do the next one, and it says between 20.5 and 25.4. So, Kylie, I'm not going to do it yet, but what do you think it is? Look at the graphics between basically 21 to 26, which you can see the exact numbers over here, but 21 to 26. This is the non-rounded version, but it's 21 to 26. So what would you say over there? Good morning, Aaron. 21 to 26. What do you think it is? How much area? Between 21 to 26, what do you think it is? Between 21 to 26. And this is why the drawing can help so much. If you have this drawing, not a good guess. We'll give you points for the guess right there. Tell me now, between 21 to 26, what percent of area is that between 21 to 26? So between 21 to 26, what percent of area is that? Good guesses, good guesses. Between 21 to 26, what percent of area is that? 2.35, exactly. Now, if you want, I can go into how this is obtained. It is 2.35. And the reason is you always want to, here's the biggest thing. You always want to make these drawings. You always want to draw out your curve, mark on your curve where things are at, and then shade the area to show you. We can use the applet too if the question had us doing that, but it has us using the empirical rule. But you want to draw it out, look where it's at, and then see if the numbers tell you the answer. So have the drawing at all times that you can see what the answer is. And the reason it's 2.5 is because outside of here, or 2.35, excuse me, is 2.5. That's completely above here. Above here is 0.15. So what you're actually doing is you're taking the total 2.5 and subtracting off the 0.15. It combined them together on me. So you're subtracting off that area and you're getting not 2.5, but 2.35. Does that make sense? This is 2.5 shaded right now, and then you subtract that off and get 2.35 because you're subtracting off from the 2.5, the 0.15 right there, to get you the 2.35. And it's 0.15 because 99.7 is in the middle, leaving 0.3 total on either side. Half of that is 0.15. And once again, you can go across these numbers to make sure they add up to 100 because you've covered the complete curve right here. Kylie, is this making sense? Let me know. It is a lot, and these take practice. They take a lot of practice to get these correct right here. And now it wants the percent over 15.6. Great job, Kylie, right there. I think you got this one. Try to shade it, and I'll show you the answer in a second. What percent of area is over 15.6, which is 16 on our curve? So what percent of area is over 15.6? What percent of area is over 15.6? What percent of area is over 16 on our curve? It's kind of an ironic answer. Don't worry about being wrong. Kylie, you got it. Extra points right there. Big points. You are correct. And it's because 68% is on the inside. You can actually add up the numbers. You could literally just add up this, this, and this and get 16. But you could do above is 16% and below is 16%. Check they add up to 100. And Kylie, you got it. Above that value is 16% of the data. And we've now gotten a no. What did we do wrong? Over, below, 5.8. No, look at this. I did a comma. It was not a mistake. It was a comma. I mean, yes, that's a mistake, but I mean, come on. I was like, what did I do wrong? That was a comma, not a period. It was all the answers were correct except Brian put a comma, which I would gladly give you your points back because that's just put a comma instead of a period. I was like, I swear I did these all correct. I was like, which one of these did I do wrong? And then I saw the comma. So easy to make mistakes right there, and entry errors happen all the time. Let us know if you ever have one of those. What should we do next? We got Kylie here, we got Christopher here, we got Aaron here. Just pick a question, especially even if I'm doing one. Say, hey, can you do this one next? Chapter 5 is a tough chapter. It takes a lot of practice. Don't enter commas instead of periods. Which one of these should we do next? It's your pick. I'll pick one here in a moment. Some IQ. And this is the quiz, right? It's the quiz, right? Chapter 5, part 1 quiz. Some IQ. Okay, let's do this. Here we go. This one's a bit weird. I should get it right. Ones that kind of blend the idea of what's an odd z-score. So let me ask you this. When is a z-score kind of odd? When is a z-score kind of odd? When is a z-score kind of odd? Like, kind of an outlier. Because it's subjective when it's an outlier. When is a z-score kind of an outlier? Like, it starts to become an outlier beyond this value. When is the z-score kind of an outlier? A z-score is kind of an outlier. Well, kind of. So z-scores range from negative infinity to infinity. And, well, so like at what numeric value would a z-score be odd? So at what numeric value would a z-score be odd? At what numeric value would a z-score be odd? Good answers in the chat. At what numeric value would a z-score be odd? At what numeric value? I didn't know anything. At what numeric value would a z-score be odd? Thoughts? At what numeric value would a z-score be odd? And then go more extreme than that. Well, so z-scores are defined by oddness the further they are away from the mean. Around the mean right here is pretty normal. And sure, we can go a little bit further out. That's pretty normal. Then you have high. Now, these are not like really high. It's a little high. Then you have outlier. Then you have extreme. So a z-score is more typical when it's closer to what? A z-score is more typical when it's closer to what? Nice answers, Noel, right there. That's when it gets unusual. Outliers generally begin outside of -2 and 2. And a z-score is more typical when it's closer to what? A z-score is more typical, closer to the mean, which is 0 on what we call the standard normal curve. That's because on this curve, everything here is a z-score. Those are all z-scores on the standard normal. You could, of course, write your context below and add the data with a mean of, so this would be a mean of 100 and a standard deviation of 10 to give it context if you had some sort of test that you were putting on here. But we always write the z-scores down below it. So now that we know this, a z-score of 1 is not that weird. So it wants to know when is something unusually high. And we would say a z-score of 2 is unusually high, and we would only see it's got 3 right there and then 1. Anything with 1 is no. So 2 is unusually high, and 3 is very rarely. So all we do right here is, what are they going to want? Or greater than. So they just want us to go up 2 standard deviations, so it'd be 120. I'll show the math on that. You go here and go 96, which is the mean, plus 12, plus 12. And then that's 2 standard deviations and then 3 standard deviations. And what you'd want to do, especially get some really good practice on this, is go over to your curve right here. So you'd want to go right here and do 96, then 108, which is not that high. And then 120 is unusual, and then 132 is extremely unusual. Does that make sense to see it right here? So you can see where, outliers would begin. This is where unusual nature begins. And then this is where extremely unusual, like very unlikely, would begin. So you can see the values of 2 standard deviations above the mean, which is the z-score. Z-scores of 1 are not that weird. A z-score of 1 occurs a lot of the time. A lot of the bulk of the data is close to here. Like there's a lot of data around there. So it's not unusual to see a z-score of 1. It's like if I told you the mean of the test was like imagine we have a test in our class and the mean is an 80 and the standard deviation is 7. So we'd go right here and the mean would be 80, then 87, and then 94, and then 101. And then you go down 73, and then you go to 66, and then 59. So 87 would not be that unusually high of a score. 94 is pretty darn good because it's 2 standard deviations above the mean, and then 101 is like, wow, or rather, I need to get a Rebel Day. It's not too far, it's just very unusual. If you heard your friend got 101, you'd be shocked. If your friend said I got an 87, you'd be like, well, a lot of people got an 87. You can see by the bulk of the data, the concentration of area around this, that a lot of people got an 87. Christopher knows, wow. So 101 doesn't have much data near it. There's very little observations around it, meaning 101 is a very extreme, unlikely thing to occur. You'd be like, whoa, you aced that test because you're 3 standard deviations above the mean. But if they're 1 standard deviation above the mean, they had scored above average, but they didn't get that high of a score. It's like, well, a lot of people, 16% of people scored higher than you according to the empirical rule. So that's why it's not that unusual, because there's a lot of individuals who would have scored higher than them. Does that make sense? 16% of individuals would have scored higher than your friend here who scored an 87 because they have a z-score of 1. Does that make sense? Like, it's subjective, what we call unusual. Like, I know the top 16% is a little high. I mean, it's good. You want to be in the top percentages, but it's not like being in the top 0.15%. This is the top 0.15 because 99.7 inside, 0.3 outside. So that would be extremely unusual right there. Extremely unusual. Does that make sense, Noel? And we can do more questions. Pick a question, we'll do it. You name the question, we do the question. Pick another question, any question you want. You're stuck on it, we'll work on it. We got a lot more in here. Ask away. Yep. If it says 2 standard deviations and 3, because 2 is unusual and 3 is extremely unusual. I wish they said it that way. Like, 3 is an extremely unusual thing to occur. That'd make it a little more obvious what they're looking for. Like, 2 is an outlier. 3 is an extreme outlier. I guess it does depend on the question. 2 z-scores are always the same, as in they always mean the amount of standard deviations something is above or below the mean. So 2 is always an outlier and 3 is an extreme outlier in all instances. 2 is an outlier and 3 is an extreme outlier. More questions. Surely someone's got a question. Surely someone's got one question. Oh, I don't need another. Suppose your statistics professor reports your grades as a z-score. We should do that. Suppose your stats professor says, here's your score on the test as a z-score. Here we go. Oh, man. Your friend got a z-score 1. What does that mean? Let's put the notes in here. And feel free to ask a question, right? You can always ask a question while we're working, and I'll put it in line for the next question to be done. So you can always say, hey, I would like my question to be next. Chapter 5, Part 1 quiz. Suppose your statistics professor. Okay, let's take a look at it. Suppose your statistics professor reports your grades as z-scores and you got a 1.82 on the exam. Now I'm going to make this easy for you right here. Turns out the exam was out of, or had an average of 1,000 with the mean of 100. Your z-score is 1.82. What did you score? So think about this. Use all that information up there, and I'm going to start a drawing. And if you don't know, that's fine, but think about what a z-score tells you. If you know what a z-score tells you, you should be able to answer the question. Also, doing a drawing is really going to help answering this. So try to tell me in the chat, what did you score on the exam? So you want to do your drawing. Got to draw your normal curve. The mean is 1,000. And go up. Try to answer it. You can do this. This is something you should be able to know. And the reason I'm drawing this out is so few people draw this out. So few people take the time to practice and just say, wait a minute, this is going to be a lot of information. So what did you score on the exam? The exam had a mean of 1,000. This is not in the question. We're just pretending. and the exam had a standard deviation of 100. So what did you score? You had a z-score of 1.82. So what did you score? Anyone takes a guess, you get points. Anyone takes a guess, you get points. So don't worry, just take a guess, and you get points. Very close. You were very, very close. You're on the right track. So here's the thing. What does a z-score tell us? A z-score tells us how many standard deviations above or below the mean someone is. So since this is the z-score, right? Oh, that's not the z-score. The z-score is in green already. Well, isn't the z-score between here? So are you starting to see it? I want you to see it. If you can see it, that's all the better. Because you're 1.82 standard deviations above the mean. So why not do this? The z-score can be used to find the observation if we do observation is equal to mean plus... Yes, Kylie, you got it. And Noelle is starting to see it. See, and look with the graphic, Kylie, big points right there. Kylie got it. And you can plug in the values right here of 1,000 plus the 1.82 times the 100. And you will get the value right here of the observation equals to 1,182. Because think, it means you scored 1.82 standard deviations above the mean, so you can plug it into the formula, the mean plus the z-score times the standard deviation, which is a reworking of observation minus mean over standard deviation equals z-score. So if you know the z-score formula, you can rework it to solve for the y value. So that goes back to our question here. What does this mean? The score was 1.82 standard deviations higher than the mean. Your friend got a z-score of -1. What percent of your class scored lower than your friend? So your friend got a z-score of -1. So what percent of the class scored lower than your friend? Your friend got a z-score of -1. What percent of the class scored lower than your friend? Your friend got a z-score of -1. What percent of the class scored 16? Great job, Noelle, right there. And because the z-score can always just be used, and it's because of the 68 rule. So it's 68 inside, 32 outside, 16 in either hand. And so these drawings right here, and great job, Sophia, right there. More points in the chat. And I hope seeing that if you have a drawing, it just helps, because then if we have our z-score drawing right here, you can instantly see a z-score of -1, and you can remember the 68 rule, 32 outside, 16 in either hand. Problem solved. Let's do another one. Keep asking those questions. We're doing Chapter 5, Part 1 quiz, or whatever you want to do. But drop those questions in the chat while we listen to one of my favorite songs right here. It's practice. The more you do of these, the better you get. And they can be really tricky. Good morning, Braden. Give me some Chapter 5, Part 1 right here. We got another 15, 20 minutes. Might go a little bit longer because I was a little bit late. And then we're going to do some correlation in class. Can we get 3 more done? 3 more super tough questions. Question 6. So each of my questions are different, unless it's a homework one, Sophia. Question 6 is going to be different for me. Let me know the first 3 letters of it, and I can do it. The first 3 words of it, or AST. Maybe that would tell me. But tell me the first 3 words of yours or so, and I'll try to find it. If it's the quiz, it's different for every person. If it's the homework, it's the same. So if it's question 6 on the homework, I can go find that. If it's your question 6 on the quiz. In incoming NBA, let's go find it. In incoming NBA. That is my question number. The weights is here. Ah. Uh-oh. Where is it? Here it is. Question number 4 for me. Okay. 36. 13. An incoming MBA student took. Okay, an incoming MBA student took Placement exams in economic and mathematics. In economics, she scored an 85. In math, she scored an 87. The overall results of the economics exam was a 75 with a standard deviation of 7, while the mean of the math was a 67 with a standard deviation of 12. Now we're going to figure out which tests they did better on by turning these into z-scores. Now, this all boils down to, Leo knows it.
Notation, brother.
Notation. So we need to make a table like we did for that question. I want you to tell me, we need to go right here and do the following. I'm going to put 6 spots on this table, and I want you to tell me what goes in spot 1, 2, 3, 4, 5, and 6. This will be math, and this will be econ. And this will be mu, this will be sigma, and this will be y. Okay, because we're going to just do the formula, observation minus mean over standard deviation. So what goes in spot 1 or 4? Go ahead and start telling me. Marking your notation is key. A lot of the test 3 especially is notation. If you don't know notation, it's not good. Sigma stands for population standard deviation. That's the thing I just highlighted in green. Mu stands for population mean, mu, mean. And Greek letters are for Greek parameters or population parameters. And then y is the observed value, like what someone actually scores on a test. So see if you can find any of these values. Type in the chat like value 3, value 6, and I'll confirm the answer. Can you find any of these values? Spot 1. Here we go, like spot 1 is going to be 75 and 4. So spot 1 is 75. The overall economics had a mean of this? Yes. There we go, that. And also 67, that is correct. And for math, ooh, maybe. Or, and then what is spot 2 and 5? 2 and 5 would be pretty easy to do now. 2 and 5 would be what? 2 and 5 would be what? What would 2 and 5 be? Good work. We're just finding the things to put in the formula. Observation minus mean. How far are the values away? Spot 2 would be 7. Yep. There you go. And then the observed is what they actually scored right here. And they go in order. So we're just going to plug in the values right here. And I guess we could write them. I think reverse the math and econ. So, whoops. This is why we color code them. 87, 85, and then it goes, econ is 7 and 12, and then math is 67 and 75. And then we're just going to plug them in. So if you look at what we do now, that's music. That's not me disappearing. Great job on the deviation right there. And great job, Sophia, too. Let's raise some points. So 87 minus 67 over 12, that's 20 over 12. 20 over 12 is 1 and 8/12, which is 1.666, repeating. And then that is the one for the math. That's math. Econ is going to be observation of 85 minus mean of 75, which is 10 over 7, which is 10 over 7. Sevens are weird. I think it's going to be 1.43. We're going to check this one, though, because I don't know my sevens as well. So 10 divided by 7 is 1.43. Apparently, I do know them. And so there we go. Right there is the numbers. And she did better in math because her math score was a 1.66 versus the 1.43. Is that making sense right there? So she scored this many above in economics, 1.43 above the mean. And then in math, she scored 1.67, rounded to 2 decimals. Above the mean, is she did better in math because she scored more above in math. How are we doing on that one? Really good question. And once again, it really comes down to marking your
notation, brother.
If you can mark the notation, the question gets a bit easier. All we did was then plug the numbers in. Observation minus mean over standard deviation. You're welcome, Sophia. Yeah, feel free to ask. I think the color coding can really help. I didn't color code the ones down below, but I can do it right here real quick. Observation, oh, these do equal a z-score. That's the whole point of finding this, is to find the z-score, or we'll do a different color real quick. Define the z-score over here. So, there we go. On the z-score. That's the z-scores that we're trying to solve for. and observation minus mean over standard deviation. So observation minus mean over standard deviation. I know, it really is helpful. And then you get a difference divided by a standard deviation. So just going through the problem, finding the values that you need, making a table, and that can really just narrow down. And you saw we did it elsewise when we made tables to solve values over here. We did the same sort of idea with color coding. Okay, another question. We got time for at least 2 more. Just drop the questions in, and then you get a little help video on how to do the question. So let us know which one you're working on. Oh, someone gave me something. What's this? What is talking points? Oh, my talking points. Oh my gosh. I got talking points. Whoa. That's like some super special talking points. I can talk now. I'll take a look at that soon. I think Mike might have swung by. Mike, you still out there? I would have had him come in here. Hello. Oh, wait. Hello. What should we do next? What should we do next? What question should we do? A company that manufactures rivets. Watch this. Boom. A company that manufactures rivets. I saw it earlier. It's a common good question right here. It's got a tricky one at the end that won't trick me today. Wow. No tricks on me. Okay, 42. Let's try to do one more after this. Stat 201. This quiz destroys people. And it makes me sad. Where's my... Makes me sad. Because you can do it. If I can do it, you can do it. If I can do English, you can do math. Sometimes I can do English. So right here we see the company that manufactures rivets, like bolts and stuff, and they have a shear strength, like they'll break apart and bad things happen. So with this right here, we see a mean of 750. Where's the mean go on a distribution? Well, they all have it, so it doesn't help us. So, as The Rock would say, it doesn't matter. Where does the mean go on the distribution? You see right here, there's the mean that stands for normally distributed. The mean goes at the where of a distribution. Shape, something, spread. That's the spread. You know, wait a minute. Okay, I want you to look at this. When you see this right here, it is the center. Great job, Noel, right there. I'll show you some points. Do you remember when we talk about shape, center, spread? I don't know if I said this before, but look at this. This equation is shape, center, spread. Because the shape is normal. The center is the mean. And the spread is the sigma. That is shape, center, spread. Shape is normal, center is mu, and spread is sigma. And then you just have to know how to take this information and apply it to the graphic below. Well, they're all normal. That doesn't help us. They all have a mean of 70/50. That doesn't help us. The standard deviation of 40 is where we can see that the only one with a standard deviation of 40 is this graphic right here. So there we go. 750, 790, 830, 870. We got it. So now it asks, when would 710 be unusual, or is 710 unusual? If you look at where 710 is at, it has a z-score of what? Go ahead and tell me the z-score of 710. What is the z-score of 710? What is the z-score of 710? -1. What percent of observations are below -1? Using the 68% rule of the empirical rule, or 68% part of the empirical rule, we already got part of this. So what percent is below -1? Well, 68% inside, 32% total outside. So what's one of my arrows worth? 16%. Great job, Kylie, right there. And then you do your trick. If you write these down, you make sure that it adds up to 100% by going across it. Great job, Ethan, right there. So now it's 16% would be at or lower than that. So we marked it, we saw it, and about 16% would be lower than that. So what percent would we expect to fall below 830? We go to where 830 is at. 830 has a z-score of what? Go ahead and put it in the chat real quick as I start to mark this. 830 has a z-score of what? What would 830? Great job, Christopher, right there. 830 has a z-score of what? 2. And so that's where 830 is at. And now think, if 95% is inside, good morning, Clay, and 2.5% is on either side, what percent is below this point? What percent is below this point? So you can do tricks. There's lots of tricks you can do to where you go right here and you do above and you do below. 97.5, you got it. Because 2.5% above, and we'll mark out this 2 for the z-score, because we don't need it right now, and 97.5% below. And then you check to make sure that adds up to 100, and you've got it right there. 95 inside, 5% outside, 2.5 either side, and then that leaves 97.5 below that point. Last but not least, I hate this last question. Really, don't focus too much in on it because it asks things in a weird way. We don't like that here. And it just wants to know 6 standard deviations below the mean. So all it's asking is below the mean 6 standard deviations. So go to your mean of 750 and subtract the standard deviation. Now we're at a z-score of -1, -2, -3, -4, -5, -6. You can also multiply, a lot of ways to do it. Just go 6 standard deviations below the mean, enter in the value, make sure you've selected below the mean, and check answer. We should get 100. Check answer, 100. We got it. And we might have time. Should we do one more quick one? 1,000 would be how many below the mean? So 1188 minus 1,000 divided by 72. There we go. Which of these is more unusual? It'd be this one. The 1,000's further away. There go. Oh, it's like multiple people. Select the correct answer. The first tax exam had a mean of this, standard deviation of this. The second had a mean of this, standard deviation of this. Reginald scored 80 on the first test. He scored the mean, so he has a z-score of 0. Oh, he scored higher on the second test. Oh, and then so he scored a 0 and he scored a 1.5, and that's his 0.75. Sarah got a 3 on the first test. Yeah. Sarah did better. The sum of Sarah's standardized scores is, and on the second test, it's 2.5. I think that's right. I think I did it right in my head. There, we got it. I was running the z-scores in my head on that. What way would be considered unusually low for such an animal? So just go, this is the 2 and the 3 thing again. So go down 2 standard deviations and go down 3. So 10, 8, 1, minus 82. Again, there's first answer, done. And then equals, I think we do this again. There we go. There's 3 standard deviations. 2 is unusual, 3 is very unusual. And then Megan took language exams. Anna scored an 81. Megan scored a 73 on the first. On the second exam, oh, she scored the 81 on both. Overall student scores on the first exam. Do you curve the quizzes? Oh, let me see. Send it to me, Noel, and I'll take a look. Scores on the first exam were mean of this, standard deviation of this, mean of this, standard deviation of this. To qualify for honors, a major must maintain at least an 85 average across all language courses taken. So far, which of the 2 qualify? Well, Megan does not qualify, and Anna neither qualify. Neither qualify because they don't have an 85 average. Which student performance was better? So an 81 is the mean for the first, and it's 0.6 standard deviation. So you got a 0 and a 0.6. And then Discord's good. Yeah, you can Discord me the message and I'll do it. Thank you so much. Ooh, and she's got a z-score of 1 on that one. Got a z-score of 1. And then on the first one, she had a z-score of, I think Anna did better. I might get this wrong. Didn't write all that down. That was a tough one. That was a lot of numbers to juggle. After examining a child in its 2-year checkup, the boy's pediatrician said the z-score for the child was at this, so they're below average. He is this many standard deviations below the mean. That's what it means to be a z-score. Normal curve, mean, standard deviation, they all have the same mean. 68.95 is all correct, so it's the standard deviation. So it looks like this one right here. Middle 99.7 is 6.12 to 43.44. And then above 31 is a z-score of 2, so that's 2.5. Between 31 to, wait, where's it going? 31. Oh, I'm looking at the wrong curve. Oh, did I look at the wrong curve for this one? I did. Oh, I gotten that wrong. It's the top curve we're looking at. And then 31, I saw that was wrong. That's 13.5. If you're wondering what I'm doing, I'm using my memory of this curve right here to do the answers on this. We'll head off here in a moment. I don't know. I like working these questions. The worst cars get less than and a z-score of 2, so -2, 12.34. That should be right. How many more? Ugh, I don't know if I can... Shifting data by adding a constant does not change the spread of the data, and spread is part of standard deviation, and standard deviation is part of spread. What is the mean for shoe sizes after we change and run this formula on it? So for men, the mean was this, and the standard deviation was this. No, you got this, Christopher. Which part are you worried about, Christopher? I'm just having some fun here doing these questions. This is the service one. Which one are you? Chapter 5 is one of the tougher chapters. But what are you wondering about? I just like solving questions. I like doing questions. So I just can't wrap my head around a lot of the stuff. Which, like chapter 5 is one of the tougher ones. So what I would say is this. Here's Christopher, my really good advice. Did you get the study guide I sent you? Do you have the study guide? If you have the study guide, we sent out a study guide, and I'll maybe mention that at the start of class. I sent out a preparing for the test early. So here's the biggest thing. And if anyone's watching this right now, we'll end office hours here in a moment. But I would highly suggest emailing me, or I could post this on Discord too. If you notice right here, we're on day 2, 917. At this point, you should start reviewing chapter 2. Now, Christopher, the test is going to look a lot like what? What work do you do that the test looks a lot like? Like, what assignments do you do where it's like, that's going to look like the test? What does the test look like? What assignments do you do that the test looks a lot like? If you had to say the test will look most like which assignments? The test looks most like which assignments? Canvas content. Canvas content. So good answers right there, the Canvas content, because they literally come from the test banks. So when you're doing Canvas content, take screenshots of the questions, use all your attempts, write down every single one of them, and think like, this is what test questions look like. So we'll do more of those. Also, we're doing a Kahoot on Friday, but I would start going through, like question review right here. You said pull up the video, and I've got a question from what the test might look like for chapter 2. We'll solve this and we'll end right here. So here's the question. It gives you a bunch of data, and then it says, what is the average? So how would you find the average for these numbers? To find the average of these numbers, you simply add them up and divide by the total. So you can see right here, I show you the math. So try to pause these videos, especially if you're doing them, and be like, okay, I have to add all the numbers up and divide by the total. So that's what they add up to total. To get the average, you add all the numbers up, and then you divide by the total, and there is the average. The next question says to you, what is the median? So how do we get the median? And these are the skills you want to practice. Like, how in the world do I get the median? Well, first, put all the numbers in order. So you want to take all the numbers right here, and I say this in the video too, so you're seeing me narrate the video. Put all the numbers in order. Doesn't matter from least to greatest or greatest to least. It doesn't matter. And then find the middle number. Since there's an odd amount of numbers right here, you will have an even number, and there you go right there. There's the even number. Katrina, good to see you there. And that's how to find the median position. I don't always show that because that does confuse people sometimes. That's just the position of the median. Next, you want to go right here, and you want to see what's the next question we have right here. Next question is, use the jump output below to calculate the IQR. So let's end office hours with this. Who can tell me the IQR? Who can tell me the IQR? What is the IQR for this data? Can anyone tell me the IQR to end? Throw some points again. We'll make Katrina a mod. What is the IQR to end? What is the IQR? Someone might have said right in that moment. Nope. Does anyone know the IQR looking at this data? 16.5, you got it. IQR is Q3 minus Q1, and that's how you find the IQR, and the IQR stands for the range of the middle 50%. And so these videos right here walk you through, they explain what's going on, and the median does not have to be between these, like it doesn't have to be directly the average, and you see that with data. Great job, Ethan and everybody. So I want you, the biggest thing to do is start early. Don't be like, I'm gonna stay all night the night before. No, 10 to 20 minutes a day. Look over these topics, look at the review sheets we have, look at the concepts we have, see what you know, see what you don't know. Yeah, so this is the easier chapters. Like, these are the ones that you just get them down and be like, do I know how to find the median? He gives me some numbers. Can I find the median? Can I find the mean? Do I know what the IQR is? Christopher, you got this right here. We're giving you some positive energy. The IQR is just found by doing Q3 minus Q1, and then you just write that down a few times. You say, how do I find the IQR? Q3 minus Q1. You look at some data. You say, can I find the IQR in that data? You find the IQR. Christopher, you got this. Let's do a fun ending. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!